Yes, turn the scope time way out. This is the cell I got. This is a 340 stainless wire mesh thing. It's like a filter. Anyway, it's sealed at the bottom, but it's floating in the can. There was 3 ppm distilled water put in there yesterday. I'm getting a few bubbles here and there just from tuning this around, but the waveform is more interesting. So turn that all the way out. Obviously, this is a whole longer period of time smashed together. But there's a very fine notch that this I don't even know what you call this. This is the step charge that's occurring. So this is reading right across the cell. We're on 20 volt scale, so it's probably from 0. We're looking at 20 to 30 volts or so an average. So it's a real sharp tuning, and I can almost get, it goes right out if I get too far out. I can almost control the number of steps in there, and they do tend to lean. So I think this has to do with the heterodyning. When the wave differential changes on the reflective wave, that is what does the choking to cause the number of things here. It's just strange that there's all that high frequency in between, and I can only get this effect in one specific range. I'm almost all the way up. I mean, it works with that one up too. I just have to tune it back to where it's at. But that's such a tiny one. But it doesn't seem to work on any of the smaller ones, obviously. The meter almost looked like it read like, I don't know, 34K kilohertz at some point, but it's having a lot of trouble. So if I try to look at down, damn it, just the peaks, yeah, it doesn't know what it's doing. It's seeing the low frequency from here, but, or I don't know what I'm doing. That's possible too. But see, it won't pick it up in the center reader. So we go all the way out. You see what it looks like. These start to occur. So the normal frequencies here, if I cut it off, you see, anyway, that's all. It's just an interesting state with a much higher frequency that I can get a hold of. This thing wants to act like sounds like an old tuning an old radio when that wave starts to occur. Alright, now I lost it. I gotta find it again. You can see a reversal in the wave compounding that happens based on the frequency. So these waves do, they shift their superposition, is it? And that determines whether or not in this case, the gated pulse happens on the leading or the trailing edge of the wave. It seems anyway. Damn it, I lost it. What do you do with those? Right there, we start to get it. I lost it. There we go. It's real sharp on the first channel signal. So I can get it at a few different frequencies. It's not specific to one when that condition occurs, but they have to be pretty close together and on the max scale, which I don't know what it is. It's 10K or above. So there's a good one there. Let me get that display off of there. You see it's a whole bunch of frequencies in a ramp up. So maybe this is more indicative of the step charge, but it's strange. Or is it happening here at the same level? But I don't think we're getting anything here. I'll get a couple bubbles here and there just from going through the different frequencies, but resonant cavity, huh? The what was it? The Dave Lawton guy said that he measured the pipes. He calculated a resonant frequency of the pipe, the 314L stainless pipes, 1 inch and 3/4 inch diameter inside of it. Those were technically a tuned waveguide from the looks of it. He would measure the length. You can mathematically calculate the resonant frequency, the audible resonant frequency, like a tuning fork frequency, of the length of tube and diameter, but you can also hang it from a string, and dampening is the key, right? So that's why Stan Meyer had the drilled holes in every rod and inserted nylon screws into the rod so that he could control the absolute placement. Number one, the parallel, surface area, he could control that top and bottom, but also it provided minimum, a way to, a mounting method with minimum dampening, because that rod needs to sing, it needs to vibrate, it needs to sit there and vibrate with the outer one in unison, and then it behaves more like a resonant cavity waveguide. Anyway, that's all for now.